Hello viewers, in today's class we are going to discuss some important results related to matrices and determinants, right? So here we have written these seven important results from matrices and determinants, and we have to find the values of these seven results corresponding to this square matrix of order 3, right? So here we are given this matrix of order 3, and we have to find the values of determinant of 2a. Then we have a determinant of 2 times the transpose of the matrix A, then determinant of the inverse of matrix A, and then determinant of minus 3 times the inverse of matrix A, and then the determinant of the adjoint of this matrix A, and then we have the determinant of A times the adjoint of A, and then we have the determinant of adjoint of A, right? So let us start, and let us first find the value of the determinant A corresponding to this matrix A, right? So here let us denote the determinant of this matrix A as determinant A, and we'll find first the value of this determinant, right? And we'll find the value of this determinant by expanding this determinant along the first row, right? So what we will get, we'll first take 1, and then we have 1 1 2 1. This is a very easy problem to evaluate a determinant. Then we have minus 3, and we have 2 5 2 1, and then we have plus 4, and we have 2 5 1 1, right? So let us simplify it. So we have 1 times 1 minus 1 times 2 2. Here we have minus 3, then 1 times 2 is 2, minus 5 2s are 10, then we have plus 4, and here we have 2 minus 5, right? So here we have minus 1, then we have minus 3, here we have minus 8, and then we have 4 times minus 3, right? So here we have minus 1, this is plus 24, and this is minus 12. So we have minus 13 plus 24, that is equal to 11, right? So the value of the determinant corresponding to this matrix A is given by 11, right? And here one more thing, the order of this matrix is 3, so let us denote the order by n. So the order is equal to 3, right? So the value of n is 3, right? Okay, so once we have obtained the value of this determinant A, that is 11, let us find out the values of these results one by one. So now let us first take the result number 1. So here we have to find the value of the determinant of 2 times the matrix A, right? So here what we will use, we'll use this result, that is, if we have k, a scalar or a number, a real number here, then the value of the determinant of k times this matrix A is equal to k raised to n times determinant of A, right? So here if when we take this k outside, then we'll take the power of k as n, and n is the order of the matrix A, right? So here if we compare these two results, then the value of k is 2 and n is 3, and the value of the determinant A is 11, right? So here the determinant of 2 times A is 2 raised to 3 using this result, and here we have the determinant of A, right? So 2 cube is 8 and determinant of A is 11, so we have 88, right? So the value of determinant of 2 times A is equal to 88, right? Now let us take the second result. Now see, in the second result we have to find the value of 2 times the determinant of 2 times the transpose of the matrix A, right? And from the theory of determinants we know that the value of the determinant is same as its determinant of its transpose, right? So again here we can write this result by making use of this formula. So here we have k is 2, so we can write 2 raised to 3 because the order is 3, and then we have the determinant of the transpose of A, right? And the value of the determinant of the transpose of matrix A is same as the value of the determinant A, so we can take the value as 11, right? So here 2 cube is 8, and here this value, that is determinant of the transpose of matrix A, is 11, so this is again 88, right? So here we can write 88, right? Now let us take the third result. So here we have to find the value of the determinant of inverse of matrix A, right? So we know that the value of the determinant of inverse of matrix A is the reciprocal of the value of the determinant A, right? So here we have already calculated the determinant of A as 11, so we have 1 over 11, right? So here we can write 1 over 11, right? Now let us take the fourth one. See, here we have determinant of minus 3 times the inverse of matrix A, right? And again to calculate the value of this result, we'll make use of this one, right? See, here the value of k is minus 3, so if we take this minus 3 outside, then we'll have minus 3 raised to the order of the matrix A, right? So here n is 3, so here we have 3, and we have the determinant of the inverse of matrix A, right? So minus 3 cube is minus 27, and we have just calculated the value of the determinant of the inverse of matrix A as 1 over 11, right? So here we have minus 27 over 11, right? So the value of determinant of minus 3 times the inverse of matrix A is given by minus 27 over 11, right? Now let us take the fifth one. See, here we have to find the value of the determinant of adjoint of matrix A, right? And we know that the formula for finding out the determinant of adjoint of A is given by determinant of A raised to n minus 1, where n is the order of the matrix, right? So determinant of A is 11, and the order is 3, so here we have 3 minus 1, so this is 11 square, that is 121, right? So the value of the determinant of adjoint of A is 121, 1, right? Now let us take the determinant of A times adjoint of A, right? So we have the determinant of A times adjoint of A, and the direct result for determinant of A times adjoint of A is equal to determinant of A raised to n, right? So here we are directly using the results, and we are not deriving the results here. In some other videos we'll discuss the detailed method of getting these results, right? So here we are directly using the given results. So here the determinant of A times adjoint of A is the determinant of A raised to n, and determinant of A is 11, and n is the order, so this is 3. So we have here 11 cube, right? And 11 cube is equal to 1331, right? So this is 1331. So here we can write 1331, right? So now let us take the last result. So here we have the determinant of adjoint of A, right? And the direct result for finding out the determinant of adjoint of A is given by a determinant of A raised to n minus 1, where n is the order, and here we have the square, right? So we have to remember the direct results for these statements, right? So here the value of determinant of A is 11, and we have here 3 minus 1 square, so we have 11 raised to 3 minus 1 is 2, so this is 2 square, so we have 11 raised to 4, right? So 2 square is 4, and if we calculate the value of 11 raised to 4, this is given by 14641, right? So this is how we can find out the values of these results by making use of direct formulas.